Here is LabView, and this is the panel I created for the reading of the parameters of my frequency generator and power supply. As you see, I have the main frequency, the gate frequency, the gate duty cycle, the amps with a gauge meter, the watts dissipated, that is the voltage applied times the amps measured. Okay. Here are the real-time graphs that plots the voltage, the current, and the impedance. Here is a temperature sensor that I use for the snubber. And here I control a parameter of the LabView for the number of samples to read. Okay. I can make a big panel if I want. The modules I use is almost not completely used, so let's try to show you. This is the CDAC 9172. CDAC 9172. Here's the frequency generator, the power supply. My power supply has this variac that is fed with 250 volts. Okay, has the indicator for the voltage for the amps, and here I used a similar variac. I opened one like this and wound 18 gauge wire. There's maybe 100 turns or maybe more. I don't remember now. So here I get from 0 to 250 volts, actually a little bit more, but 250. And here I get from 250 to 100 volts, step down. So the gauge of the wire allow a higher current to be used. Okay, so I can use more watts from this variac on the output, even applying a lower voltage. Okay, here I have a fan for blowing some air on the variac. Here the switch for it, voltage regulator. And here let's show you the frequency generator I got. Basically I get the frequency range switch, 4-way switch. Here I have another switch that I use for the capacitor. I can change the capacitance of the PLL to get other ranges for the frequency. Here is the output from the feedback signal, from the signal going into the pin 14 of the PLL. I hope you can see feedback signal there. Okay. Here the switch for automatic or manual frequency. Here is the frequency offset pot, okay, for the PLL. Here the manual tuning. Okay, you see it's in manual. If I lower, the LED will blink slower. Okay, and here the LED for the feedback signal, for the phase lock-in indication. Here is a capacitance variable for the gate side, for the gate generator, for the gate frequency generator, and it's variable capacitance for the fine-tuning of the higher range. And here the frequency range is a 6-way button. It changes capacitors here, okay, for changing the gate frequency. Here is the gate frequency button, okay, and here the gate that cycle, okay, and here the output for the gate for easy reading in the oscilloscope. Okay, here my setup. Here's the oscilloscope. Okay, this one is the differential probe meter. Okay, this is the high voltage probe. Also this one is high voltage probe. Nice. This is my multimeter. That is very nice. Can read through RMS, DC plus AC. And that's all for now.